So a ball is kicked in a truck at an angle of 45 degrees. It is intended that the ball lands in the back of the truck, which has the length of 2.5 meters. If the initial horizontal distance from the back of the truck to the ball is 5 meters, what is the maximum minimum velocity so the ball lands into the truck? So over here I wrote out all the information that the question gives you, and the initial distance is 0 meters and the final distance is either 5 meters or 7.5 meters, because it can either go from 5 meters to land in the truck, the minimum length it needs to land in the truck, and then the maximum length it could go to land in the truck would be 7.5 meters, because the back of the truck is 2.5 meters and the distance of the ball away from the truck is 5, so you add those together and you get 7.5. And you don't know the time it takes, and you know that the acceleration in the x direction is 0 and the acceleration in the y direction is 9.8 meters per second squared. And then the initial velocity, you don't know which is what you're looking for, what they're asking for, but they're asking for to a minimum and a maximum value. And then the velocity for the max height, or the final velocity, is 0, which is the max height. When it hits this point, it's 0. So then I resolved my initial velocity into x and y components right here. And for the x direction, I got VI cosine theta, so it would be VI cosine 45, and then the y direction I got VI sine 45, and that's their components for this angle in the y direction. And then I know we're solving for distance, so I know we have to use one of these two formulas. And I know that we have to use this formula because we don't know the final velocity, and this formula includes the final distance, but we don't know the change in time, so we have to calculate the change in time first. So in order to calculate the change in time, I use this formula over here. The final velocity equals final initial velocity plus acceleration times time. And if you plug in your values for that, you get that time equals VI sine 45 over 9.81. But you have to multiply this by 2, so because your total time is the time because that's the time it takes to hit 0. So it has to go up. So that's just the only up. So it goes down too. So it's also, that's why you multiply it by 2. So the total time is 2 times VI sine 45 over 9.8. And then since that's the time, you have to plug in this formula for the minimum. For the velocity minimum, you use 5 meters because that's the shortest distance it could go to make it into the truck. So once you plug in everything, you get, well, you plug in all your values, and you get that the initial velocity equals the square root of 24.525 over sine 45. So once you calculate all that, you get that the minimum velocity is 7.0 meters per second. And then you do the same thing with the maximum velocity, but for the maximum velocity you use 7.5 meters because the ball is 5 meters away from the truck, and the length of the truck is also 2.5 meters, so you have to add those two together to get the maximum velocity, because that's the farthest it can go, is 7.5 meters without going past the truck. So once you plug in all your values in the same equation to find the max, but you use 7.5 meters instead of 5. And after you calculate all that, you get that the initial max is 36.781 the square root of 36.7875 over the sine 45. So you get that the maximum velocity is 8.6 meters per second to make it into the truck.